Let's talk about Lesson 10, Activity 3, Question 4. Given that AB is equal to AD and that C is the midpoint of line segment BD, we're asked to prove that triangle ABC is congruent to triangle ADC. And once again, we've been given kind of an incomplete proof, and we're asked to provide the missing pieces. So let's review what we've been given and take it from there. All right. So it's given that AB is equal to AD, so of course this immediately appears in our statement and reasoning. Statement being the given statement and the reason being that it is given. Now, we're also given that C is the midpoint of BD, of line segment BD. And this is also restated in our proof. The order here, it wasn't listed second. That's okay. We'll see the reason why in a second. So let's take a look at our picture now and understand what we're being asked to solve. So we've got triangle ABC, which is triangle ABC. So that triangle, that it is congruent to triangle ADC, so the triangle that now appears in white. And in fact, why don't we go ahead and just shade that in. So we're proving that these two triangles are congruent. And again, I've mentioned this before, there's often more than one way and one order to complete a proof. Since we've been given a partial one, we have to go off of their method and kind of backtrack and fill in the missing pieces. So if we take a look here, I always skip down to the bottom and say, okay, well, what was their approach? And when they prove that these two triangles are congruent, they use the side-side-side congruence postulate. So that gives me a clue as to what I'm going to be dealing with in this proof. For example, side-side-side congruence postulate means I'm not really going to be dealing with any sort of angles or angle measures in this proof. Okay, let's go back to the beginning. AB is equal to AD. In the next line, they claim line segment AB must be congruent to line segment AD. And why is that true? Well, we've had a bit of practice by now with this, so hopefully you recognize that this is because of the definition of congruent line segments, right? If two line segments are of equal measure, then they must be congruent. So this is because of how we define congruent line segments. And I'm not going to write that in. I'll let you select that on your own. Now I know that that's the whole answer to the problem, but that doesn't mean we stop here. We should still explore the rest of the proof, make sure we understand it, because this proof might reappear with a different piece of it missing, right? So let's continue. Okay, so we've established that line segment AB is congruent to line segment AD. Now since we're doing this side-side-side congruence postulate, you know that we're going to end up trying to prove that line segment DC and BC are congruent, and then this shared line segment AC must be congruent to itself. So let's see how we go about this. Well, the first step they take is to say that C, this point C, is the midpoint of line segment BD, and this was given to us, and now you understand why that second step was inserted where it was. So C is the midpoint of line segment BD. Again, this was given to us. Now think about what it means to be a midpoint, right? It means that this point is appearing exactly in the middle of the line segment. So by definition, this point C bisects line segment BD by definition of a midpoint. And be clear that that is not definition of bisect, it's by definition of midpoint, because we were able to kind of gather that based on the fact that they told us C was a midpoint. Okay, so if C bisects BD, what does that mean? Well, now you think about the definition of bisect to make your next claim, which is that line segment BC is congruent to line segment CD, and of course this is due to the definition of bisect. So now we've established that AD corresponds to AB, that they're congruent, that CD and CB are congruent to one another. Now we need to prove that AC, that line segment, is congruent to itself. So we make that claim, AC, line segment AC is congruent to itself. And this is true by the reflexive property of congruence. So any line segment, any angle, any polygon is congruent to itself. That's the reflexive property of congruence. So AC is congruent to line segment AC. So now I have each side of each triangle has a corresponding piece in the other that it is congruent to, a corresponding line segment. So I've got my side, side, side all established, which means I can now claim that triangle ABC is congruent to triangle ADC by the side, side, side congruence postulate.